This is the first of 3 videos outlining the solutions to the 2021 Hsc Maths Advanced exam. In this first video, we're going to look at the multiple choice questions. So question 1, which of the following is equivalent to sine squared 5x? So if we go to our reference sheet, we find the Pythagorean identity, which is cos squared x plus sine squared x is equal to 1. And we can just form a new identity by replacing the x with 5x. And that gives us cos squared 5x plus sine squared 5x is equal to 1. Taking this cos squared term over the other side, we end up with sine squared 5x is equal to 1 minus cos squared 5x, which is B. Question 2. The probability distribution table for a discrete random variable x is shown. What is the expected value of x? So remember, we want to do the sum from x is equal to 1 up to 3, and we want to multiply x by p of x. So we're going to go 1 times 0.6 plus 2 times 0.3 plus 3 times 0.1. And just in the calculator, that is going to give us 1.5. Question 3. Which of the following represents the domain of the function f of x is equal to ln 1 minus x? So let's start with our basic log function. It looks like this. And it cuts through the x-axis at x equals 1. And there's an asymptote here on the y-axis. Now, we have a couple of transformations happening here. And in the way it's written, it's a bit muddled. So I'm actually going to change it. I'm going to factorize the negative out. And I'm doing that so that I can have x in the bracket first. And this is going to clear up my horizontal translation. So we've got two transformations here. We have a dilation, which is actually a reflection in the y-axis, and a horizontal translation. Now, order is important when there are multiple transformations. And the general rule is to do dilations first, followed by translations. So we're going to dilate this first, or reflect it in the y-axis. So it's going to come over here like this, and we'll cut through at -1. And then we're going to translate this 1 unit to the right to bring it down through here. And the asymptote will actually be at x equals 1. So the domain is going to be everything from -infinity up to 1, but not including 1. And so our answer is D. Question 4. The number of downloads of a song on each of 20 consecutive days is shown in the following graph. Which of the following graphs best shows the cumulative number of downloads up to and including each day? So here we've got the original graph and 4 different options, A, B, C, and D. All right, so we want the accumulation of all of these daily totals. So we can see that we're rapidly increasing here. So that would fit this graph here and this one, but not A or D. So we're down to 2. Now we're going to peak here, and then we're going to slow down a bit. So that's going to mean that it's going to be C, isn't it? Because this one doesn't slow down, it keeps increasing. So our answer is C. Question 5. Which of the following best represents the graph of y is equal to 10 times 0.8 to the power of x? So let's start by working out the y-intercept. And that occurs when x is equal to 0. So we're going to do 10 multiplied by 0.8 to the power of 0. This is equal to 1. And so our y-intercept is 10. So it's not B and it's not D. Now secondly, does this represent growth or decay? Hopefully you know that this is decay, because each time I'm multiplying by a fraction less than 1, which means this 10 is going to get smaller and smaller and smaller and smaller. So can you tell which one's the answer? It must be A. Question 6. There are 8 chocolates in a box. 3 have peppermint centers and 5 have caramel centers. Kim randomly chooses a chocolate from the box and eats it. Sam then randomly chooses and eats one of the remaining chocolates. A partially completed probability tree is shown. What is the probability that Kim and Sam choose chocolates with different centers? All right, let's start by completing this probability tree. Now this is a without replacement experiment because Kim eats the chocolate. She doesn't put it back in the box. And that means that we need to consider what has happened before we work out these probabilities. So let's start up here. A peppermint chocolate was chosen, which means there are only 2 peppermints left, but there are still 5 caramel-scented chocolates. And there's only 7 all up. So the probabilities are going to be 2/7 and 5/7. And remember, those 2 numbers have to add to 1. Now let's have a look down here. This time a caramel chocolate was chosen, which means we have 3 peppermints still, but only 4 caramels. The probabilities are going to be 3/7 and 4/7. Quick check, they do add to 1. Probability that Kim and Sam choose chocolates with different centers, this is what we want. Now remember, as we go across the tree, we multiply. As we go down the tree, we add. So we want the probability that we choose peppermint and then caramel, or the probability that we choose caramel and then peppermint, which is 3/8 times 5/7 plus 5/8 times 3/7, which is equal to 15 on 28. Question 7. The diagram shows part of the graph y equals f of x, which has a local minimum at x equals -2 and a local maximum at x equals 3. Which of the following shows the correct relationship between f double dashed of -2, f of 0, and f dashed of 3? Okay, f dashed of -2 is here. This is testing concavity. This is concave up, so our second derivative is positive. F of 0 is testing the y-coordinate. We can see the y-coordinate's below the x-axis. It is negative. And then finally, f dashed of 3 is here. That's testing increasing, decreasing, or stationary. Here it is stationary, so this is equal to 0. So putting them in order, we have f of 0 first, and then f dashed of 3, and then f double dashed of -2, which is A. Question 8. The graph of y equals f of x is shown. Which of the following could be the equation of this graph? Now there's quite a lot that we know here. We have a single root here and a triple root here, so this is a quartic curve. Furthermore, it's upside down, so there's going to be a term in x to the power of 4 that is negative. So we're looking for negative x to the power of 4. Can we eliminate anything? Let's have a look here. So negative x times x cubed, well, that's going to be negative x to the power of 4. X times x cubed, this one's positive, so it's not B. X times negative x cubed, that one's negative, that's a possibility. And then finally x times x cubed, that one's positive. So B and D are gone. Now what else do we know? Have a look here again at these zeros. We've got a single root here, and we have a triple root here. Right, A is telling us there's a single root at x equals 1 and a triple root at -2. That's not right, is it? Let's have a look at C. We have a single root at -1 and a triple root at 2. Yeah, that's it there. It's C. Question 9. Let h of x equal f of g of x, where the function f of x is an odd function and the function g of x is an even function. The tangent to y equals h of x at x equals k, k is positive, has the equation y equals mx plus c. What is the equation of the tangent to y equals h of x at x equals negative k? All right, we're going to start by trying to figure out whether h of x is odd, even, or neither. So we'll start with h of negative k. Now we know that this is going to be equal to this. We're told that g of x is even, which means this. And that is equal to h of k. And so h of x is an even function. Now let's just draw a basic even function and see if we can figure this out. I'm just going to draw a parabola. We have a tangent at some point k where k is positive. So something like that. All right, let's find negative k and draw the tangent in. It's not a very good graph, sorry. To be straight. All right, firstly we can see that the y-intercept of these two lines is going to be the same. So it's going to be plus c. So we can eliminate c or d. Now if the gradient of this line here is m, then the gradient of this one must be negative m. So our answer is B. And question 10. The line y equals mx is tangent to the curve y equals cos x at the point where x equals a is shown in the diagram. Which of the following statements is true? Now I've gone and put the boundary values in, pi on 2, pi, 3 pi on 2, and 2 pi. And you can see how I've drawn 2 pi slightly to the right of a. And that's because this line is tangent to the curve cos x. It can't go through that point 2 pi 1, because at that point the tangent is flat. Now let's start by looking at the gradient m, and we're going to use this triangle here. This distance here is not quite 1, because that dotted line there has length 1. So the gradient is not quite 1 over a, so it's less than 1 over a. Can we eliminate anything here? Less than 1 over a, less than 1 over a. This one can go, and less than 1 over a. So at least we've eliminated 1. Now let's consider the line that goes through 0, 0, and this point 2 pi 1. Now I've drawn it up in Desmos, and you can barely see the difference between those two lines. But when we zoom in, here's 2 pi here. The blue line is the line that goes through the origin and the point 2 pi 1, and the green line is the tangent to the curve. And can you see that the gradient of the tangent is going to be bigger than the gradient of this blue line? And the gradient of the blue line is 1 over 2 pi. So we want m to be greater than 1 over 2 pi. It's not here, it is here, it's not here. Our answer is B. The next video will cover the first booklet of short answer questions.